Welcome everyone. Today we'll talk about these topics here: Simulation Live, Creo Ansys, and Creo Flow Analysis. And what we'll do is talk about this agenda right here. I'll be sharing lots of models today, and my presentation will be also become available to everybody as well. And if you have any questions, please ask during this session. If I don't get to them, anybody can reach out to me anytime, and I will get back to you as soon as I can. So we'll start with Creo Simulation Live. We added contact simulation in 901, so that's not a 10.0 improvement or enhancement, but it's something we did during that 10 development time. So I'll go ahead and show that to you. The solver update to Ansys 22R2, some new results as well. So actually, I'm going to go. I have slides for each of these, so I'm not going to talk about them right here, but we'll just kind of go in this order. Okay, so. All right, so first is Creo Simulation Live, contact simulation. So now you can, instead of the entire assembly bonded, which is currently in 9.0 and earlier, we can now add small amounts of frictionless sliding contact. Okay, it's not going to be something you can do with a snap fit, something really crazy. It's small strain. Okay, that's really what the key here, but it's going to give you more realistic results than you would if things are glued or bonded together. Okay, and then next we updated the solver to 22R2. So with that, we get the most current Ansys technology. If you want to look at like what specifically is the new, you're going to see some much higher accurate solutions when it comes to fluids in particular. But we'll get higher accuracy in all of them, and just better efficiency as well with current graphics cards that are out there. We have new results in CSL. We didn't get as far as I wanted to. We're going to do this a lot in Creo 11. So we did finish vectors and we got a few new structure results, but we have a lot of days and a big commitment in 11 to really just make every result possible that we have available to us. And then we have new contact detection. So if you're familiar with the way Creo Simulate has worked in the past, we only could do one-to-one contact, and you had to do them, each one by one. But now we've inserted the Ansys contact proximity DLLs. So what that means is we now have the same contact detection that Ansys has sort of been working on for 30 years, 30 plus years. So now we can detect contact much more efficiently, very fast. And we can also do now one-to-one, one-to-many, and many-to-many. And we also have a repeat button in here too. So you're gonna love the way that we can do contact now in CSL and Creo Ansys. And I didn't play that video. Here we go. Okay, so, and then lastly, we have some changes in the UI. We have moved the inspect deviation up into the ribbon. And really what that means is that in the past in Creo 9, you could always see the solver geometry. Okay, so what that meant is you could see like a Swiss cheese if your graphics card couldn't render all the geometry. Well, we've lost that capability. We don't have that capability anymore to see that geometry of what the solver can see. So that's a step backward a little bit. We're going to improve this in 11, where we're going to have hopefully a new tool to really interrogate what did the solver see, what did it not see. But in the meantime, we've moved the inspect deviation open to the ribbon so that you can see more clearly where's the red area, where's the blue area, and where did the solver not see it, where did it add it. Okay, and that's really the only thing we have available. Then we also have taken the export to Ansys Mechanical and made that a default now. It used to be controlled by a config.pro option. And obviously, since we can't see the solver geometry, we've taken the render facets away as well. So, okay, so let's go ahead and show a couple things. So I'll kind of go back and forth between Creo and the presentation. Here's the first is contact simulation in Creo Simulation Live. So here's the default, I don't have any contacts here. I click on simulate, it goes ahead and looks at this and it says, well, the stresses are near these edges here because it's all glued together. Well, that's not really true because because I have bolts in here, but it glued that whole, it fused all that together, so it's not going to show me any stresses in there. Okay, so if I would turn that off and go back to here, let's turn that off. Now let's go ahead and do contact and say detect contacts by automatically. So we can just pick on the entire thing and let's just leave it. Let's leave it as go to no separation. So we can say free, which is, sometimes in a simulation you don't want surfaces to touch. Okay, and sometimes you want just small strain. We're going to say no separation for that. There's a couple other options here. Override behavior for existing contacts and create one-to-one, because by default it's going to be more efficient. You're going to see this Ansys proximity detection. You're going to see lots of many-to-many contacts, which is fine. We can go ahead and solve that. I'm going to say okay to that. There's one more thing you should be aware of. There's under options and simulation, there's one more thing related to this. It's called auto detect contacts in inactive studies. Okay, because if you don't touch contact, it'll bond everything together. But as soon as you invoke that and say, I want to do a contact, now it's going to have a new behavior. So what do we do when you have 10 different studies? Well, do you want, when you add geometry or change geometry, do you want it to always auto detect contacts in inactive studies, or do you want to say on study activation? I think study on activation is probably the best as far as the resources are concerned, but you can choose which one you want. Default is always, so it's always going to be doing it in the background. It's up to you, but I wanted to make that option available or aware of to everybody. So I have contact now detected. I just go ahead and click on simulate now. And now I will see, if I do my cross section, I will see some, stresses now inside the geometry, which is more realistic of what I should see. Okay, there you go. One of the biggest enhancements and really complaints from customers is that I don't have realistic contact in CSL, and now we do. Okay, so let's go ahead and close that. And open up another model, which is going to be this one. All right, so let's look at fluids first for new results. I have fluids turned on. Now, what I want to do is I'm going to click on simulate. And the new fluids, I'm going to turn off results here and go to vectors. Now, notice when I turn vectors on, I will see just curves in here, and I'm not going to see the vectors very well. And I hope I'm not going to crash here, although I'm starting to feel like, oh no, it works fine. You notice it's kind of hard to see, which we're going to fix this. It's going to get fixed before we ship, because what you should see right away is I should see the count a little higher, and I should see this width. I should see this when I invoke that vectors, which is fantastic. I can see these long vectors here, super visual for the velocity. And we're gonna get vectors working for pressure and even for stresses and for strain. We're gonna get that working for all physics in 11. But currently now, and if I click on animation, I don't get a great animation unless I spin, and we're gonna fix that too. This is a little bit of a, an issue we're having getting that to work perfectly, but that's going to be addressed before we ship. Okay, so if you ever demonstrated this before we ship, you have to sort of slowly spin this to see the animation correctly. All right, I'll stop that. And then the other things we have in Creo Simulation Live, let me activate the other study, the structure study. I always forget to make my material here. let's see, steel. It's not water anymore. Okay, and I think I have some boundary conditions set up already. I've got a force and a constraint. Let's just click on simulate. And the new results now we have are strain results. So I have all my directional strains, max principal strain. Okay. So that's a big enhancement we now have with CSL. We have the strain results. And if you have a assembly, then you have contact stresses you'll see as well. I don't have an assembly here, but that just makes sure that you're aware of that. So you have strains and contact stresses. And then lastly, let's go ahead and open up here to go to contact. This little model. Now, contact detection, again, if you're familiar with this in the past, all you could do was one-to-one. So now either in Simulation Live or in Ansys, either one, it's very similar. Like if I look at like this, I did this with like a model, this model when we were just starting development in Creo 10, and all I could do is one-to-one, okay? And you see it takes 23 contacts to do it. Very prone for error and takes a long time. So let me get rid of those. So 23, and now I'll do the same thing. I'll say contact. And I want, notice we have multiple reference selectors here. Okay, so I can put multiple things in here. So for example, on this top surface there, I want that first reference. And then for the other model, I want this one and this one. Okay, and we want it to be frictionless. Now I get a repeat button too. So I hit repeat. Cool. So now I'm ready to go. I'm going to say the first reference up here is going to be these three surfaces. And the second one is going to be this, this, this. Oops, and then that one. And that's going to be frictionless too. Hit OK. So there, I just did the same thing I did with those 23 references, or 23 contacts. So it took me probably 5 minutes if I was good at it. Now I can do the same thing in Creo Ansys or Creo Simulation Live in, very short amount of time. And it'll solve the same way. So that's super fantastic, much more efficient with contact. All right, so let's go back to my slides, make sure I didn't miss anything. Well, only thing I didn't miss was, is over in the Creo Simulation Live. You can see I have inspect deviation right here. That's the only thing. All right, so let's go ahead and go back to our slides, moving right along. Now in Creo Ansys, we have true, nonlinear material. I'm sorry, nonlinear contact and material. I'll get to that. So we've added frictional, frictionless, rough, contact behavior can be specified. We also have formulation options. We'll show all those to you. And we can detect contacts by radius or factor, stiffness factor. We pretty much took every option that we had available and put it into this part of Creo Ansys. This is an Ansys advanced license is required. So for nonlinear materials, nonlinear contact, and also for multi-physics, structure and thermal together, which we'll show as well, you have to have the advanced license to do those. All right, let's go to the next slide. This is nonlinear materials. So we can do three kinds. We can do neo-Hookean, hyperelasticity. So there's a rubber material in the library that works fine for this. Linear orthotropic elasticity, okay, like a wood or rolled material, depends on direction. And then we can do bilinear plasticity. Okay, so that's a large strain analysis. And we define that using the linear hardening option. And I'll show that to you in the example. And this is really going to get us this ability to do this this type of stress strain relationship. You know, you have your linear relationship here, and then you basically have that bilinear line where you can now be into the plastic deformation area. Okay, but it is a straight line. Okay, which is what most people want in the end. Okay, they don't want this multilinear plasticity, which some people do, but if you want multilinear, then you're gonna have to buy something more expensive. Actually, Creo Simulate does multilinear, but in Creo Ansys, bilinear is going to be available to customers. And let's go to the next one: combined structure and thermal. Now you can, if you're running a thermal study, you can add structure, or if you're running a structure study, you can add thermal. And really basic, put this into an oven and see what kind of thermal expansion, thermal stresses are going to be on the model. Okay, let's go ahead and show those. And I want that thing to go away up there. There it goes away. Okay. Let's start with just a basic nonlinear example. I'm sorry, we're going nonlinear contact first. Okay, so that's the first slide I showed. So here's a simple example. This is just in Creo Simulation Live. If I click on simulate, it gives me an answer of 89 MPa. Now it looks like the stresses here. This is a bonded, okay? There's a bonded. The stresses are on that little pin, okay? So 89 MPa. Let's minimize that. Let's go to this one here. This is now on the Creo Ansys side. I have one as bonded and one as with contact. So if I go to the bonded one and I say von Mises stress, I'm at 96. So 89, 96, we're very similar, that the stresses are highest, over here as well. So it picks the same area for the stresses that are high. Just wanted to verify that, you can go between Creo Simulation Live and Creo Ansys and get very similar results when it comes to bonded. But now if I go ahead and change it, this one has now some frictionless contacts. Okay, so now, for example, like that can slide over there. Those two surfaces, the blue and that one there, on both sides. We also have some more areas in the bottom that can slide and rotate. Also, that bolt there, they can go ahead and rotate on that. Okay, and then we also have a bunch of bonded areas where we should have bonded areas. And now if we look at this, and then we also put in some joints. So you can do a lot more to make it much more realistic. Now it can rotate on those joints there. And if we look at results, we should get higher stress results because we are, I guess, MPAs, because now we're not bonding the entire thing together and making it really stiff. So stresses are down there quite a bit still, but we're at 189, we're a lot higher. But we're going to get much more realistic results because we have more tools here to use. And those stresses and those bonded areas are no longer there because it can slip there now. Okay, so this is a good little example to show to people, and you can actually do it in front of them, do all the contacts in front of them as well. I've included another example in the materials that I provided. This little example right here. And this one just has a lot of different contacts. So you have bonded, we have frictionless, rough, frictional. And a really nice way to do this is to go ahead and explode it like this. And then go back to here and say review geometry. And you can see all of your different contacts are here. I can say, where's my frictional ones? Okay, those are right there in blue. Where's the frictionless? Okay, that's a bolt on the inside there. Then I did a rough one on the other one. Okay, no separation, and then bonded. There's your bonded ones where the nut is holding onto the bolt and the nut on the washer. Okay, so it's a good little example to show people, to get the point across. You can do a really simple example. And I believe somehow I didn't run this yet. Okay, so let's just assume it actually doesn't take very long to run. This runs in like 2 minutes, but 2 minutes is an eternity on a call like this. But let's go and open up the other one where we have, so let's contact. Let's go to nonlinear materials now. And look, it's the same model. All right. So I took the same model, but I put a gigantic force on it. I just said out in the front there, let's make this, 25,000 pounds. And what I've done to make it nonlinear materials is, if we look at the plate, the 2 plates here, and we go to properties, you can see I have the linear hardening defined. Okay. You also have to have a tangent modulus assigned. So those 2 things, I'm sorry, and also the tensile yield stress. So you change it to linear modeling, add a tangent modulus and a yield stress, and then the solver recognizes that that's a material that it wants to use bilinear plasticity when it runs. Okay, so same contacts, and I look at results. Let's just look at von Mises. And of course, you should always look at the deformation first. And if I look at the scale of 1, we can see that we have, some deformation happening. We have a gap there. The bolts are holding tight, which it should. And then if we go to von Mises stress, here's that one, same type of displacement. And then we should look at also the equivalent plastic strain. And you can see we have plastic strain, which means it's definitely entered the plasticity world. Okay, and I just used that one component, that one plate, to look at the results in that one. And if you ever have trouble in not seeing results, okay, make sure that you, and I have this as a config.pro option, is that there's an option here called solve for all result types. So I always check that on because I don't care if it takes an extra 20 seconds to run to get all the results. I want all the results every time. So I'll get all my contact stresses, I'll get all my plasticity, all those things should be given to me. If you don't check that box, you're going to be only getting a subset of all the results that are available. So I choose to turn it on. By default, it's off because we want to conserve resources for customers, but turn it on if you want to. I recommend it. Okay, so that's nonlinear materials example of that. I think I have one more example of that over here, this little boot example. Here I have a simple fixed surface in the bottom, and then I'm pushing on this at 20 millimeters. Okay. And as far as the materials for this, I'm sorry, I did it here. Yeah, I signed it here. Or I signed it somewhere. I'm not sure why I'm not. Oh, here, let me do this again. I'm gonna cancel. I did it here. It's recorded in my tree. I'm sorry. So redefine silicon rubber, and properties of that are neo-Hookean, and then you put your 3 coefficients in there. And then that'll get you a neo-Hookean response. cancel out so it doesn't think that I changed it. And then cancel again. And let's look at displacement. You're gonna do like a 1-to-1, and then look at the deformation. Now, what we're missing in this, and I recognize we missed it, we didn't get it all the way done, is that we do need graphing to happen. We want to see the stress strain results. We want to see, force reactions over time, and we don't have that in 10. We have the basics of nonlinear materials and nonlinear contact, but we didn't get the graphing done. That's one of our highest priority items in 11. Then this will be fully complete. Let's go to equivalent plastic strain. I'm sorry, equivalent elastic strain. There should be no plasticity in this one. And there we go. So I can share these models with you, very simple models. This one does take a little longer to run. It's not quick. The nonlinear material ones are actually for bilinear plasticity. Those are pretty fast, but this one takes longer. And also what you're gonna focus on or find out in this is you're gonna play with these steps a lot too. And unfortunately, there's no great way to predict this. I believe if I leave this at default, I don't get a result, it'll fail. I had to add a lot of initial sub-steps to make this work. And this was the magical combination for me. Took me a couple times to get this correct. Again, bilinear was very quick. I think the one I shared with everybody is that happened the first time, worked fine. Didn't have to change this at all. I changed to automatic. It was fine. But here I did have to play with these sub steps to make hyperelastic on this example work. Okay, let's go back to our actually, not one more. There's one more. I'm sorry. Let's see. Minimize that. And let's go to the multi-physics example. Really basic, simple model. Just going to bring this into Creo Ansys. I'm going to just say it's fixed in the center, and we have a prescribed temperature of 150 degrees Celsius. And let's just run it right now. Takes very little time. All right, it's completed. And then just pick on the displacement result and just wait till it gives us the green star. And there we can see our displacement. All right, so there's an example of a really basic academic example of thermal expansion. All right, let's go back to our slides. Here we're halfway through. Actually, we're halfway through. Multi-body support. Okay, so now in Creo Simulate, you're going to see the word bodies in many places when you're defining a temperature load, material assignment, contact definition, some element control, size controls, heat loads, and also results too. I can see results of a body. Okay, so now we have full multi-body support of Creo Simulate. So if you want to do that and with one model, we sort of did it before. We definitely didn't do contact though in a body, but we could do temperature loads and some other things by volumes. Okay, but now we fully support multi-body. And lastly, in Creo Flow Analysis, we have a few more options when it comes to the streamlines. So we have a single streamline. We have a relative animation speed. We have arrows or spheres inside there. You can see this one's got arrows. I'll show that to you. We also have an export to a GIF, and we also have simulation scenes now too. And what's nice also is that whenever you define a cross section or an iso surface or an extra streamline, for example, those are all saved with the project. So next time you open the project, all those results that you customized are retained with the project. Okay, so let's go and show those. So we'll start with simulate. So here I have a multi-body part, might look familiar to you. Let's take that into Creo Simulate. And we're going to just apply like a displacement over here and there. So it's fixed. And let's apply a force on the top. So I'm not doing anything multi-body yet, but I forgot to set this up. So we'll still push down this like 200 pounds. Okay. And then next is we're going to apply materials. And again, now I can apply materials by body. Okay. And let's just make this simple. I'm just going to pick everything, maybe except for the bolts. Okay, I'll pick the 2 bolts. And I'm going to say this is going to be steel. Good. Hit OK. Let's do one more assignment of those 2 bodies here, those 2 bolts. And let's say they're going to be stainless steel. Good. Okay, so there's the first thing. And then I mentioned before, you can do like a temperature by a body. Right there it is. I can do oh, I see there's a question. So how do I get rid of this? Let's go down a little bit. I want to do I can do interfaces now. Again, like contact between a body to body. Okay, so I can do surface to surface, or also I can do body to body. Just want to show that to you. Okay, I'll just leave it bonded. And then lastly, I can do element size, again, by a body. Okay, I'm just kind of showing those to you. So those will give you the ability to do all these functions now when you have a multi-body part. Now let's just run a simple study here. I believe already. Let's just run it and look at results. I want to show the last result here is that if I wanted to look at stress results for the entire thing, I get this. But if I want to just see one component, I now have the word bodies here. Okay, bodies, and I only see I want to see like the result for this body right here. Hit OK, and then that's the only part I see. Okay, so you can always do that with assemblies. Now you can do that with a body. All right, so full body control or body support. All right, so last thing we'll do is the Creo flow analysis. I think I have it already open here. Here we go. So let's go ahead and go into here. Applications, Creo flow analysis. And let's just say a new project. We're going to create the fluid domain. Hit OK, that's fine. Let's select it now. And material-wise, let's make it water. And then we'll use turbulence and streamlines. And let's generate mesh. Be very simple. So this is our fluid body, and we have our boundary conditions already done for us. So we're going to pick on one of them. So here we're just going to say it's going to be a a simple flux of 0.001, and we want to see some particles, 50. And then for the second one over here, let's just make that a outlet, and we say run. Okay, so now you'll see our streamlines there with those arrows. Okay, so let's go ahead and take a look at some of those things. We have streamline. And you see we have in the menu here, hopefully you can see that, we have show indicators yes or no. So if we say no, it's like the old ones, right? So now we say yes. So much better with the arrows though. We can change it from arrows to spheres. Okay, there you go. And then each of them are modifiable. I can make these arrows longer or shorter, you know. Here, I can make it like 20. You can see it's a little longer, back to like maybe 4, you know, so larger or smaller. And then you can define the density of them. How many do you want along the curve? Normal, coarse, fine, you know, how many arrows do you want? Default is coarse. And then if I animate this a little bit, so I'm going to say 0.005, okay. Now I have a relative animation here. So it's relative to my definition. They're slower or faster. All right, that's pretty cool. And then under project, here's where you can save an animation right here. And then it makes a GIF file for you on your working directory. And lastly here, there's simulation scenes. Okay, so let's say I like this one. I'm going to say, let's make a simulation scene. I'll say new. Okay, and then I can rename it if I want to. I believe, yeah, I can say, you know, streamline only. Okay. And then if I would go ahead and add a section, maybe, let's say it's a Y section, and that's good. Pressure, yeah, let's just look at pressure. Hit OK. There's my pressure. Then I'd make another scene. I'd say, let's make another scene, you know, new. So I'd call it pressure and streamlines. And then if I do like a ISO surface, let's say below a certain value. Actually, we want like velocity. Here's our slowest velocities, okay? And hit OK, and then, you know, there we go. So now we have all these things over here, section, ISO surface, and then we'd make another scene, you know, hit OK. So then when I would pick a scene, I should be able to pick that one and say update, or I'm sorry, apply. It also captures the view that you were in too. Go to stream 1, apply. Okay, scene 2, apply. Okay. And there you go. So that's pretty cool. Very valuable, because now you don't lose all your results once you run Creo flow analysis. And then of course, if I would now export or save my project, you know, I would be able to, you know, save projects. I would see all these results that I made in here. I think that covers everything I wanted to show you. And then I see there's a couple questions. I'm going to last thing I'm going to do is go through the roadmap. Then I'll take some questions. So here's just a view of what we accomplished in Creo 10. Just reviews of what I already went through. And then in Creo 11, here's our plan. So in Creo 11, for Creo Simulation Live, we're going to update to the 23R2 solver. And then conjugate heat transfer, we started it in 10, didn't finish it. So we'll just finish that. That'll be like the first thing we'll do. Bolted connections and preload are the #1 thing we're going to do in 11. We'll do that both for Creo Simulation Live and Creo Ansys. And we're going to also expand our structural and fluid results. And then we've got a couple backlog things that are pretty easy to do that we hopefully will make time for. We can add a bearing load in Live, a point mass, And we can also get automatic results for all the mode shapes that you asked for. Currently, you have to make a result for each one, and it's kind of a pain to do all 6 or 10 or whatever you want. We're going to try and get that to be automatic. In Creo Ansys 23R2 solver, and then we're going to finish the transient simulation. We started that in 10. This will be part of the advanced license. Now we can do a time-dependent structural simulation. Meshing diagnostics is new as well. We've been trying to figure out a good way to give feedback to customers when they have a mesh fail. And now we think we have a good solution to that. And then bolted connections, I already mentioned, will be both in Creo Simulation Live and Creo Ansys. And then improved substep animation. Today, we don't get a result for every substep. So when you animate like a snap fit or something, you're not going to see every animation step as you should. You're going to see sort of an interpolation of going from the start to the finish. So the start is correct, the end is correct, but the ones in between are not valid or not correct or accurate. So we want to do that. Dynamic cross-section, just a cross-section in general, we want to do in Creo Ansys. And then if we have time, we can add in random vibration and fatigue in Creo 11 as far as the next things we'll do. On the Creo flow analysis side, there's the top two are probably the highest priority. That again, Cimerix is a company that develops for us. So if we can get these completed, then we'll go ahead and add them into Creo. So there's an electrical or EMAG or magnetics. It's called the E-motors that Cimerix has, and we'd like to get that into Creo. And that would be just at the high level. We'd put that functionality into the premium package, and that is already sort of done. They have a lot of that already done, but we just have to do some quality and get that into the package. And also there's a real-time mode. Again, that's done as well, but we didn't love the UI, so we're doing some modification there. And that's going to be a CPU-based real-time mode. So the CFA is already really fast, but they have a way of actually doing it in real time too. So as you make changes and move stuff around, the results update automatically, which is really, really cool. Then there's a couple of also improvements around the expression editor, XY enhancements, and also putting in a fan curve and real gas database. I believe that's my last slide. So that's what we have planned in 11. We've already started many of these things. I have some Q&A. Let me grab some of these here and see if I can answer them. So please, if you want to, please put some questions in the Q&A, and we'll go ahead and answer these. Some of them are long. I'm not sure if I'm a fast reader here. Is there an upgrade path from Creo Simulate to Creo Ansys? There's not currently in the price book. I think we're working on that. So that's something that's not done yet. What simulations can be stored in Windchill? What simulations can't be stored in Windchill? So what you should be able to do is, Creo Simulation Live doesn't make any results, so you don't have any results to store. But in Creo Ansys, you can store the APR file. So when you have in Creo Ansys, if you have everything stored, you go ahead and say save as an APR, and an APR file is supported inside of Windchill with the correct version of your model. Do we have improvements on how to handle material properties in CAD from simulation to PDM? We don't currently we haven't worked on that as far as material properties. I know that Ansys has a new package that I think we're going to work on together to add Granta into Windchill. I believe that's available today, actually. So that would be something I would ask the Windchill team. Are we adding more things into Creo Ansys? Yes. So I should think about that question a little more. So never mind on that one. Is saving the flow lines as a GIF just a 2D video or something that can be used in a AR studio session? So the saving the flow lines as a GIF is just a 2D video. Now, you know, inside of Creo flow analysis, there is an area where you can, am I here still? Yeah. Where you can go into flow, and I think I can get my body. Let's see if I can do this correctly. There is an export to AR. Okay, so I can save it as an AR. I can save my streamlines to AR. If I can find it, I'm not going to find it exactly where to do it. But then you can put this into, you know, Vuforia Studio, and you can, you know, see. And I think some people have seen that in the past with the Cirrus aircraft and the snowmobile. Okay, there's a handful of people at PTC that can do that. It takes a little bit of work to do that, and we just have like a handful of people. And if you want to do that, let me know. There's a few people I could put you in contact with to do that and get the streamlines onto your model. Okay, so the trick is to export the streamlines as IGES files, and then we have a shader, a custom shader that can then shade them accordingly with the correct velocities, and then put them next to your model, and then you can make an experience with the streamlines on your model. So that's available today. It's not customer viewable. It's sort of a thing that PTC can do. Like Steve Wall can do it, and a few more people that are like AR experts. I want to do it. I've asked the AR team if we could add that as a product, and they're still considering it. And hopefully in the future, we'll have that as a customer product that they can do themselves, because there's been a lot of interest in that from many customers. All right, I don't see any more questions. Let's see.
There are two in the chat. I just want to know that their graphic cards are used in Creo 10. Creo Ansys said, what are requirements for hardware?
I just want to know that their graphics cards are used in Creo 10. Not sure what the question is there. So I guess overall the hardware requirements for Creo 10 have not changed from Creo 9. They're very, very similar. There's no new level of CUDA required for 10. So I think we're still on the same as we were before. The hardware checker. Actually, what's cool about the hardware checker is we now have the hardware checker inside of Creo. So right there is hardware check is inside of Creo 10. So now you can check it right here, because it looks like I'm all set, ready to go. And then there's just some, yeah, and 10. There's some more information here about which CUDA version supported by this driver. You know, so we've done some work to do the hardware check inside of Creo in 10. But Creo Ansys and Creo Simulation Live, the hardware has not changed. So the same hardware in 9 is, I think that's the answer you're looking for. And if you want more information, let me know. I mean, obviously, whenever you can have a better card, better chip to run stuff, it's always going to be a better experience. I have the great advantage of having a 5500 GPU. This thing is unbelievable fast. I had a 5000 before, a Quadro 5000. This card is like 1,000 times better. Things are so fast for Creo Simulation Live. It's just unbelievable. And all rendering, everything is just really efficient with this kind of card. So lucky me. Okay, so I think that's it. So thank you, everyone. I don't know where to put the models. I think someone's gonna tell me, and then I'm gonna put all this stuff that I showed today up into some folders And maybe I've done that already. I don't remember. Honestly, I think there's a different location that I gotta put them in so you can get them. So thanks. If anybody has any questions about Ansys or the products that I went through today, please reach out to me. I try to get back to you soon, but if you don't, or if you're at PTC, call me. You just hit me in Teams and we'll talk. Sometimes it's better just to talk about these things versus just an email. So thanks everyone. Have a great day. Goodbye.
Todd.